Hello again and welcome back. Today we're going to be finishing off the 2013 Cimc paper. We just got one more question to go, last question in B part, so let's take a look at what we've got. Okay, question number 3 gets its own page. The positive difference list, or PDL, that is quite a long phrase, is a set of integers is a list written in increasing order of the positive differences between all possible pairs of integers in the set. For example, the set 2, 5, 10 produces a positive difference list consisting of 3 integers, 3, 7, 10. Okay, because 5 minus 2 is 3, 12 minus 2 is 10, and 12 minus 5 is 7. Okay. So it consists of 3 integers, 3, 7, 10, which are distinct, while the set 3, 4, 6, 9 produces a PDL consisting of 6 integers, 1, 2, 3, 3, 5, 6, okay, which are not distinct. All right. Notice that we get 6 integers here because we're choosing pairs out of a set of 4. 4 choose 2 is 6. Whereas before up here we only had 3 numbers because 3 choose 2 pairs, like 2 pairs, a pair of numbers. So 3 choose 2 was 3. Alright, so we're talking about ones that are distinct and ones that are not distinct. Interesting. What is the PDL of the set of integers 3, 6, 13, 21, and 32? Okay, so we'll have to make sure that when we calculate all these positive differences, we write them in increasing order. Good to know, because that's part of the definition up here. And this question is just sort of getting us more familiar with the concept. So 3, 6, 13, 21, and 32. 3, 6, 13, 21, 32. Oh, I'm on blue. Don't know how that always happens. Three, 6, 13, 21, and 32. So to get the PDL, we need to find the positive differences. So let's see. We should find some methodical way of doing it. So how about we start with 3 and subtract 3 off all these numbers. Okay, so that's all the numbers with 3 subtracted off. And then we'll calculate these out in a moment, but let's make sure we get our list right. Let's not get ahead of ourselves. We're looking for 10 different expressions because we have 5 numbers and we need to choose pairs. 5 choose 2 is 10. Okay. And what do we got here? So now let's move up in our list. Let's take subtract off 6. So I can't do 6 minus 3, or sorry, 3 minus 6 because that would be negative. We want positive differences. We can't do 6 minus 6 because that would be 0. So we need to subtract 6 off of anything that's higher than 6. Okay. Now 13. So we've only got 2 numbers left that are greater than 13. And 32 minus 13. So now we've got 9. We should just have one more, and indeed we do. It's 32 minus 21. So now that we have them all listed out, let's start these calculations. You can grab your calculator and do them, or you can do them in your head if you're feeling confident and sassy. 11, that difference right there. I know this one's 8. This should be something like 19. But as I'm always bad when the one's digit is smaller than the other, we'll just double check on our calculator. 19, 26, 15, 7, 29, This one up here will be 3, this will be 10, and 18. So we want to write out a final statement. And remember, we need to write these guys in increasing order. So 3, then 7, then 8. We can cross these off as we go. Then we're up to 10. Let's not forget 11 down there at the bottom. 15. 18, 19, 26, and then lastly 29. Looks like we've crossed everyone out. Let's just count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have them all. And so there we have the positive difference list. That was a much bigger example. But we got through it okay, and so we really understand the concept. Got to find all the differences. And we have to put them in increasing order. So that was A part. Let's look at B part. Suppose that x is greater than 16. Okay. And the sum of the integers in the PDL. Okay, so now we're not even talking about the list. We're just talking about the PDL. So the PDL of the set 1, 4, 9, 16, I wonder if x will be 25, is 112. So the sum of the integers in the PDL is 112. Determine the value of x. Okay. So what this will amount to do is this will amount to finding, sort of setting up equations for all the positive differences. And some of them we'll actually be able to figure out as actual numbers, like 16 minus 1. And then we'll have a bunch left over in x. We'll still add them all up. We'll get a linear equation in x, and we'll be able to set that equal to 112. So 1, 4, 9, 16, and x. So let's grab ourselves a blank piece of paper. One, 4, 9, 16, and x. Okay. So what are the positive differences? Well, we got 4 minus 1, 9 minus 1. Just continuing the same method as beforehand, we'll subtract 1 off of everything. And here we have an x minus 1. So we won't be able to do anything with him yet. But we can work these ones out. And how about 4 minus everything, or 4 subtracted off of everything? That's 5. That's 12, and we can't do anything with that one. Okay, 9 subtracted off of everything, so that's 16 minus 9, which is 7, and x minus 9, which we can't do anything with, and lastly, x minus 16. So once again, 5 numbers here, and so we get 10 equations in the end. We can't always solve for all of them. We know it's going to be x minus 16, for example, since we know x is greater than 16. So that will definitely make x minus 16 the positive difference. The smaller number subtracted off the bigger number, that's always going to be positive. So we know 112 is the sum of all this. Plus, and we can add in our x minus 1, x minus 4, plus x minus 9, plus x minus 16, and we can start grouping things together. So 3 plus 5 plus 8 plus 12 plus 7 plus 15, that's going to be 50. We're going to have 4 x's, and then we're going to subtract off 1 plus 4 plus 9 plus 16, so minus 30. So 112 is going to be equal to 20 plus 4x. But really that just means that 92 going to be equal to 4x. And when we divide by 4, we get 23 is equal to x. Okay, and you can either do that on your calculator, or you can just know that 92 is 4 times 23. All right, so we were just asked what the value of x is. So the value of x is 23. Okay, we're moving right along. We're showing all our work, justifying things. For example, the x greater than 16, we just justified that, and that's why that made a positive difference. Okay, question part C. State a set of integers of the form 3qrs14 with 3 less than q less than r, so it's a sequence, or it's a set that's already ordered, for which the PDL contains no repeated integers. So we're bringing it back to what we were talking about up here. This PDL had no repeated integers. This PDL had a pair of repeated integers. Okay. So we want a set with which we get no repeated integers. All right, so PQ and sorry, I don't know why I keep saying P. I don't know why they didn't just start with P. Q, R, and S. We need to figure out some possibilities for those guys. We already know that the range has been narrowed down. So Q definitely less than 3. So we can actually just jump in and say that Q minus 3 is going to be a positive difference. So that'll definitely be in the PDL. So how about we write out the PDL just in terms of Q, R, and S. And then we can go from there. QRS14, 3 less than Q, less than R. So Q minus 3, R minus 3, S minus 3, 14 minus 3. And then we'll have R minus Q, S minus Q, 14 minus Q, and S minus R, 14 minus S, and lastly, 14 minus R, and then lastly 14 minus S. Okie dokie. So, there's really only one of these that we can calculate out. So he's equal to 11. Okay. So what can we do? Well, I'm noticing some things. For example, R minus 3, that's one of the differences in our list. But he's R minus Q plus Q minus 3, both differences in our list. So we probably have a ton of relations in our whole list that we should be working out. The problem is, without any idea of what without any idea of what Q, R, and S are, we're just going to get a whole bunch more equations. However, we do know that 14 minus 3 is 11. And so if we throw a 14 minus Q plus a Q minus 3 in there, we certainly get some relations. So that's 14 minus q, and that'll have to be equal to 11. So there's a nice relationship. But that still means that, say, q minus 3 could be 1, and this could be 10, or this could be 2, q minus 3 could be 2, and then this would have to be 9. Not really helping us a whole lot. But if we crammed this full of as many expressions as we could, knowing that they're all going to have to be different integers, 11 is very small, so there's probably only a couple ways to express it as the sum of a lot of integers with all of them being distinct. So how about we cram it full of everything we can. Right, the q minus q, the q cancel out, the minus r, the r cancel out, the minus s, the s cancel out. So we're left with 11 is the sum of all these elements of our PDL. Okay, so how many ways can we write 11 as a sum of 4 distinct integers? Well, there's not many ways. Because 10 is 1 plus 2 plus 3 plus 4, and there's only one way to do that. So 11, we could do 1 plus 2 plus 3 plus 5. That's different. And how about 1 plus 2 plus 4 plus 5? No, that's too big. Yeah, there's only one way to do it. Five plus 3 plus 2 plus 1. So these have to be, so somewhere in here we have to have a 5 plus 3 plus 2 plus 1. That doesn't mean that 14 minus s is 5, or that s minus r is 3, things like that. We don't have that. So one thing we can notice is that these guys must be 5, 3, 2, 1, but we don't know exactly which ones they are. Okay? So, is there a way to narrow it down? Well, I'm noticing things like so 1 plus 2 is equal to 3. Now, if we go back on this other page, we had a relationship like r minus 3, r minus q, q minus 3. So if r minus q was 1 and q minus 3 was 2, for example, then that would mean that r minus 3 is 3. But we already know that sort of one of these guys up here at the top has to be 3, not r minus 3. So I think we could probably narrow our relations down a little bit. I'm trying to see if there's sort of a best way to do that. Okay. Well, R is kind of a center number. So we could probably say something like this can't be 2 and this can't be 1. And this can't be 2 and this can't be 1. Things like that. What should we do? Okay. So there are 6 choices for R. R is equal to, no, how do I want to say this? Oh, jeez. So what I want to do is I want to take pairs of these guys. So R minus Q and Q minus 3, they have to be some pair in here. So 6 choose 2, 4 choose 2, that's 6. And then I can say something like R minus 3 is R minus Q plus Q minus 3. So R is 3 plus R minus Q plus Q minus 3. Okay? So we can make a little chart. Our choice of R minus Q, Q minus 3. What does R minus 3 turn out to be, and what does R turn out to be? And then perhaps what does 14 minus R turn out to be? And see if any of those differences sort of counteract each other. So these guys can be, and I don't care in what order they are, 2 and 3. So that means this guy's 3, R is 6, and this guy's going to be 8. Then we can have 1 and 3, we can have 1 and 5, we could have 2 and 3, 2 and 5, and then 3 and 5. Okay, so then this one would be 4, this would be 6, this would be 5, this would be 7, and this would be 8. Just need to add these guys up. And then R would be 7, this would be 9, 8, 10, 11, and what would this guy be? He'd be 7. So I guess that can work. And then we'd have 5. So that's no, because this would be one of these expressions already. 6, 4, and finally 3. Alright, so let's put a little blue box around them. Right? We can't have 2 things in our PDL be 5. We can't have 2 things in our PDL be 3. So that's sort of thrown out. In the same way, we also can't do those ones. So this is among the set 14 minus S, S minus R, R minus Q, Q minus 3. So we eliminate 2 more cases. So what were the remaining cases? 1 and 3 and 2 and 5. One and 3, I think it was 2 and 5 I just said. 2 and 5, okay. So then R is equal to 7 or 10. So those are now our 2 potential lists, and we can start trying to single out what possibilities for Q there are and what possibilities for S there are. So if those ones have to be 1 and 3, then the other pair, so 14 minus S and S minus R, the differences between consecutive integers, they have to be what's left over, so that's 2 and 5. So we can get choices for Q and S. We can have 4 and 9. Oops. We can have 4 and 12. Right, just adding these things up together. We can have 6 and 9, and we can have 6 and 12. Okay. So what do each of those look like in terms of their PDLs? So 3, 4, 7, 9, 14. Is that going to work? Here we have 14 minus S is going to be the same. So we have 4 goes to 9 goes to 14. That's 5 and 5. So that's the same as S minus Q equals 5. So this will not give us a unique PDL, right? We're picking one of our possibilities for Q and S. We're plugging it in, and we're just going to check, can we get some difference somewhere that doesn't work? And indeed we can. 4 plus, so 9 minus 4 is 5. 14 minus 9 is 5 as well. So this one won't work. This will not give us a unique PDL. How about 4, 7, 12, 14? Okay, so there's the difference of 5, 3, 1. There's the difference of 2. Difference of 7 there. Difference of 8 there. Difference of 4. I think this one will work. What about one of our other ones? I think the question just asked for one, so we might be done there, but let's figure out all of these guys. We have the time, because we're not actually physically writing the contest right now. Okay, so so we're sort of hunting for arithmetic sequences, really. Well, not exactly. We could have a difference here and a difference down here, or something like that. That one's not going to work because S minus Q equals Q minus 3 which equals 3. We have 3, 6, 9. 3 and 6 are 9. 3 and 6 are 12. 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 And then finally, 3, 6, 7, 12, 14. Is this one going to work? Difference of 2 there, difference of 5 there, difference of 7 overall there, 6 there, 9 there. I think this one also works. All right, what about our other option? So this was our assumption that r minus q and q minus 3 were amongst 1 and 3. How about the other way? So 2 and 5 is what they're in with. So then our other differences are 1 and 3. So what are our choices for q and s? Q can be 5, and the smallest s can be is 8. Oh, no, because we're talking about 10. So he can be 11. All right, I was going to add him to 7 again, but this means r has to be 10. Okay, we can have 5, we can have 8 and 11. We can have 5 and 13, and then we can have 8 and 13. So how about 3, 5, 10, 11, 14. So that's one of them. 3, 8, 10, 11, 14. 3, 5, 10, 13, 14. And finally, 3, 8, 10, 13, 14. Alright, so which of these will and which of these won't work? So, okay, so this one here, 8, 11, 14, that won't work. 14 minus s is the same as s minus q, which is equal to 3. And how about, so let's not skip over this one. So I think this one works. Difference of 2, difference of 5, difference of 1, difference of 3, difference of 4, difference of 6, difference of 7, difference of 8, and a difference of 9, and lastly a difference of 11. So yeah, that one works. How about this one down here? Difference of 1, 3, 5, 2, 7, 8, 4, 9, 10, and 11. So this one also works. 5, 2, 3, 1, 4, 5. Okay, we've counted 5 twice. So that will be s minus q equals q minus 3. I think these were the exact same differences as last time. We had a difference of 3. We had an arithmetic sequence, and we had a difference of 5 that was also an arithmetic sequence last time. So we have, I guess, 4 valid lists, 4 things that work. So these 2, and then I'll need to copy the ones from the other side. Uh, 3, 4, 7, 12, 14, and so both of them have a 12 in them. That's odd. So 4 and 6. So we got all the valid lists. I think we were just asked for 1 though. Let's just check. State a set of integers. So we didn't just state one set, we stated them all. That's okay. Overachieving not always the best thing, so we probably could have stopped a little earlier on once we had one set. But we worked them all out just for fun. Alright, now D part. Prove that the PDL of every set of integers of the form 3QRST with 3 less than Q, so it's ordered again, 3 less than Q, less than R, less than S, less than T, and T less than 14 contains repeated integers. Okay. So I imagine we're going to have to take a look at those differences again and perhaps use similar reasoning to the way we worked last time, but we'll get a bunch of contradictions. Three less than Q, less than R, less than S, less than T. Oops, those should be less than signs, not commas. Okay. And this guy, of course, up here, we were also given the additional information, he's less than 14. And I've mentioned this a couple times, there are 5 choose 2 equals 10 integers. In our PDL. So what are they? So these ones here were pretty important last time, from which we could basically get all the other ones. So how about we write them special at the top? R minus S, and then it's not 14 minus S, it's T minus S. And then we sort of had one that was the difference between these guys. So you might call these the first differences, and then we could have the second differences, I guess. The reason we write it, we'll write it this way is then we can maybe make some greater than or less than arguments. T minus R. So those don't. That's not a thing. All right. So we're not going to write it like first and second differences. We're just going to write it down the old-fashioned way. I thought that might help. It did not. S minus Q, T minus Q, T minus R, and T minus S. Okay. So at best, T minus 3 is equal to 10. And that's when T is equal to 13, and only when T equals equal to 13. So I don't need this. So we need all of these guys to be in 10, and T minus L will be the biggest difference. So he's got to be 10. Sorry. Did I say T minus L? T minus 3. So it is, I guess, if on paper right now, it is possible. We could get t minus 3 equals 10. If for some reason t minus 3 had to be 9, being the biggest difference, we could never get a difference of 10, and we need one of these guys to be a difference of 10. Okay, so t minus 3 is equal to 10. Now, just as with last time, we had 14 minus 3 is equal to 11, and we could express that using a lot of different integers. Let's do that again. T minus s, s minus r minus q, and q minus 3. Group these guys together. So t minus 3 is 10. We also know it's the sum of 4 different integers. And 1 plus 2 plus 3 plus 4 is the only way to do that. Any higher, if we had a 5 in there, we'd have to have a 0 or a duplicated integer. Just not going to work. So using set notation, where the order does not matter, we can say that these sets will have to be equal. We don't know which one's going to be 3, which one's going to be 4, things like that. But one thing we do know is that we still have 1 plus 2 equals 3, and now we have 1 plus 3 equals 4. So these are possibilities here. Okay, so let's think here. Oops. So whichever one of these guys is 1, we can't have him adding up too much with his neighbors. Right, we have to choose very carefully where 1 goes, because how does that keep happening? Whoa. This program causes me all sorts of headaches. All right. Can't have. All right, I think that was it. Okay. So we can't have r minus q equals 1. This 3 here is really, this e is really bugging me, so I'm just going to rewrite him. Okay. So we have to choose very carefully where 1 goes. Okay, we don't have 1 plus 4 as a possibility. So why can we only have q minus 3 or t minus s be 1? Because otherwise, maybe s minus r is 1. Then, since he has sort of two neighbors here, one of them will not be 4. And this will give us a repeat. Okay? If s minus r is 1, then say, for example, t minus s is 4. That's great. But then r minus q is something like 3, and then s minus q would have to be 4, and we've got a duplicate. So suppose q minus 3 is 1. Then we know that r minus q will have to be 4. Otherwise, again, we'd get a repeated integer. So that immediately tells me that r minus 3 is 5. Okay. But if I look at t minus s and s minus r, they're either 2, 3 or 3, 2. So t minus r is also going to be 5. Now, there was nothing special about choosing q minus 3 equals 1. If we had chosen t minus s equals 1, we'd have s minus r is equal to 4. So once again, t minus r is equal to 5. But then it's the other two. Q minus 3 and r minus q, they'll be 2 and 5, or 2 and 3. And so r minus 3 will also be 5. So since we've gone through all possibilities, trying to eliminate repeats whenever we can, the only conclusion we can come to I don't know why I keep putting in commas. So we have a little concluding statement. That we've shown it has to have a repeat. So what did we do exactly? Well, the first thing we did is we showed that since we have to have 10 distinct integers in our PDL, that means that our biggest difference, which is t minus 3, has to be 10, and that tells us t is 13. Not a big deal, but it does tell us t minus 3 is 10, And so we can write that difference as the sum of 4 differences, the sort of first differences of our list. And since they all have to be distinct, the only way we can do that is for one of them to be 4, one of them to be 3, one of them to be 2, and one of them to be 1. Okay? So from there, we realize that the number 1 very special because 1 plus 2 is 3 and 1 plus 3 is 4, and we don't want repeats. So the sort of second difference numbers would eventually be repeats unless we position 1 and 4 very carefully. They have to sort of be on the outsides. 1 has to be at one end, so the difference of the 2 lowest numbers or the difference of the 2 highest numbers. And 4 has to be the next number, so the difference of the next 2 highest or the next 2 lowest. But even with that, we were able to show that you get 2 sort of second differences that were both 5. So even when we tried to separate things, we still got a repeated integer. And so since we tried everything, we really did, there was no other possible way to make this work. We held off on repeats as long as we could, but we still got them. We can safely say that with t less than 14, our PDL is going to have a repeat. So that was a nice little proof, and that about does it for the contest. If you've enjoyed this contest, you can take a look at some of the other ones. I've got the 2011, 2012, all the CIMCs, we're doing those. And of course, you can take a look at some of the other content on the channel. But whatever you do, I hope to see you guys again in another video. So thank you so much for watching, and I'll see you next time.